Okay, so today we're going to cover section 11, and in this section it says to use several methods of factoring. So basically we're going to combine everything that we've learned how to factor into one lesson. So notice there's some guidelines or some steps here that I've starred in pink. So these are going to be the steps that you should follow in order to factor a polynomial completely. Whenever you're factoring, you should always look to see if each one of the terms has a greatest common factor. If there is a GCF, then you have to factor that out first. Then the next thing I would do is count how many terms I have. So if there's only 2 terms, this would be a clue, or even if it's like a group of things, if it's the difference of 2 squares, because that's one of the easier things to factor. Then the next thing I would look for to see if it's a perfect square trinomial, because you should remember that when you factor a perfect square trinomial, the answer is a binomial squared. Then if not, then you're going to look to see, well, is it a trinomial? If it's not a perfect square, then let's look at the last number and look for the factors of that number. And then again, if there was a number in front of x squared, then it's a little bit harder trinomial. And then step 5, if it's got 4 or more terms, then we're going to look to see how we could group that. And then we would factor by grouping. Also double check. If you can't find anything that it would factor into, then possibly your answer is going to be prime. You can always check your answers by multiplying it. Do a bunch of FOIL problems to double check that your answer is good. So let's try the first example. And notice here, if I take a look, right away I can see that there is a greatest common factor that I could factor out of my 3 terms. And once I take a look at that and figure out what that GCF is, I would divide them. Now, it's always in your best interest to keep that first term positive. So when I divide out the GCF of these 3 numbers, or these 3 terms, I'm going to pull out a negative GCF so that this first term becomes positive. It makes it easier to factor. So my greatest common factor that I'm going to divide these 3 terms by is going to be negative 4. It's also going to have a variable included, and the variable exponent is going to be the one that's the smallest, which is the n squared. So I'm going to divide all 3 of my terms by negative 4 n squared. Now, once you divide out a GCF, don't forget about it. It needs to go out in front of your problem so that you can use it to distribute back through. So I'm going to divide by the greatest common factor. So the first term, when I divide it by negative 4, divided by negative 4 is positive 1. And then when I divide variables with an exponent, I subtract them. So this will become n squared. Then for the next term, positive 40 divided by negative 4 is going to be negative 10. And then n to the third divided by n squared is just an n. And then negative 100 divided by negative 4 is positive 25. The n squareds, that becomes 1. Okay, so then now I've got to take a look. Now that I've factored out step 1, which was GCF, now I'm going to take a look at this. Is this a difference of 2 squares? Nope, it's a trinomial. So now I'm going to see, is it a perfect square trinomial, or is it just one of the more difficult trinomials? This one actually is a perfect square trinomial, and I can do this 2 ways. I can either do it by the factor by grouping or looking for the factors of 25 that give me negative 10, or I could just do the square root. So I could either realize it's a perfect square trinomial, so this will become n minus 5 squared, or if I said, well, what are the factors of 25 that add to give me negative 10, I could also write it out n minus 5, n minus 5. Either way. And then remember, the last step is to check your work. You could FOIL this and distribute it, and then make sure it does go back to the original. So again, multiplication is commutative. It doesn't matter if I FOIL these 2 first and then distribute, or if I were to distribute to this one first and then FOIL. Doesn't matter. Let's try the next one. Let's look for step 1, which is going to be a greatest common factor. Now here, the recommendations are to pick a letter and put it in order from the greatest exponent down to the smallest. If you look at this, we could either choose to do it in terms of A or B. They want us to write it in order for the letter A. So I'm going to put this one first, then this one second, and then third. It's not going to affect our answer if we don't do this, but I'll go ahead and do it. So the 3a to the 4th b plus 5a to the 3rd b squared. And then lastly, 2a squared b to the 3rd. So now I'm going to look for a greatest common factor. Notice if I look at the numbers, 3, 5, and -2, there's no greatest common factor based on the coefficients. But if I look at the variables, notice all 3 terms have an a and a b in it. So I'm going to actually divide each one by the greatest common factor, and it's going to have an a in it and a b in it, but then I'm going to go through and find the smallest exponent. So I have an a squared, which is the smallest, and then I have just the single b. So that's going to be, so I'm going to divide each one by a squared b. And then left in parentheses for the first term is going to be 3, and then a to the 4th divided by a squared b. This is going to give me a squared. The b's cancel. Over here, I'm left with a 5 and an a and a b. And then the last term, -2, and then a b squared. Now, notice by putting it in order from greatest to least based on the letter A, notice now I've got a nice trinomial here that I can actually attempt to factor. So notice it's not one of the easy trinomials. This is one of the more difficult ones where you have to multiply the first and the last terms. So I'm going to be looking for factors of -6, a squared b squared, that when I add them are going to give me 5ab. So when I do this, I'm going to use grouping now. So those factors are going to be +6ab and -1ab. So I'm going to go ahead and factor by grouping here. Remember, when you factor by grouping, I'm going to rewrite the first term. So I'm going to have my GCF out here. I'll put like a bracket. So I'm going to rewrite the 3a squared, put in either the -1 or the 6. It doesn't matter which. We're still going to get the same answer. And then finally the last term that was there. So now I can make my groups. And I'm going to look for a greatest common factor of each of my groups. So let me put my original GCF out here. My GCF of these 2 terms is going to be 3a. And then here I get a plus 2b. Over here, I'm going to factor out a -1b GCF. So it looks the same. Remember, when you factor by grouping, it has to remain the same whatever I get after I divide. This has to look identical, otherwise I cannot factor by grouping. So it does look the same. Now I have a bracket here. So now I'm going to take the a squared b, rewrite one of these underlined things. You only write it once. And then take the 2 GCFs that are out here. 3a minus 1b. On this one, the order doesn't matter. I know in the textbook, they wrote it like this. They put the 3a, and they don't put the 1. It's assumed. So the order here does not matter. And we didn't need the brackets, because remember, all of this means straight multiplication. Let's try example 3. So on example 3, it says to factor completely. Now, notice this time, it's not a trinomial, it's not a binomial, it's actually 4 terms. So what I'm going to do here is right away, I'm going to factor by grouping. So I need to make my groups. I'm also going to look to see if there's a greatest common factor that I could pull out first. That's step 1. Notice they all have in common the letter B. So I can divide all 4 of these by the letter B first, and then I will start making my groups. So I'm going to divide everything by B. There's no number, no coefficient in common, and no A isn't in common, and neither is C. So I'm going to go ahead and divide out the B, A squared C, and then minus 4C plus A squared minus 4. Now I can make my groups. So I could make a group that's right here and a group right here. My GCF of my first group is going to be the letter C. So C, and then what remains is A squared minus 4. Over here, I need to pull a GCF out, and the only thing in common is going to be positive 1. And I need to show that. So then A squared minus 4, because remember when you factor by grouping, these two things need to look the same. So then from there, you're going to group the 2 GCFs. So I get my original B that I pulled out. I put the C plus 1, and then the A squared minus 4. Now, notice I have to take a look. Can I keep going? Yes, I can. I can actually factor this further, and this becomes A plus 2. It's the difference of 2 squares. And then drop down the B and the C plus 1. So this would be your final factored answer. So again, you have to keep looking at it and say, wait a minute, can I keep going? Generally, if you've got an exponent, you might be able to keep going. So always double check that you don't want to stop too soon. Okay, so your homework for this is going to be 2 through 48 evens. And then tomorrow, we're going to cover section 12. And then on Wednesday, we'll review. And then your last test of quarter 2 will be on Thursday. And again, remember, your midterm study guide is already up there. So you should be working on that. And then maybe when you come to class, if you have any questions, you can ask me. On Monday, I will talk about any questions you have for it. So throughout this week, and especially on the weekend, you should be looking over it, and then when you come back next Monday, have any questions you have for me for the study guide. So right now you can start your homework, the 2 through 48 even. If you get stuck on anything, let me know, and I'll be glad to help you.